We use it every single second of every day, and most of the time we don't even think about it. I'm talking about fuel, that hidden energy packed into literally everything, from the food on your plate to the gas in your car. It is quite simply what powers our world. So let me ask you a question. Have you had your fuel today? And no, I'm not just talking about for your car. I'm talking about your breakfast, maybe that cup of coffee. Because this whole idea of fuel, it's way more personal than you might think. So first things first, let's tackle the biggest question right out of the gate. What exactly is fuel? Well, it all boils down to one simple idea: stored energy. At its heart, the definition is incredibly simple. A fuel is just any substance that we can burn or, eat to provide energy. It doesn't matter if it's a log for a campfire or an apple in your hand. If it's got energy locked away that we can release, hey, it's a fuel. So the most important thing to get is this. A fuel is basically an energy container. That's its whole job, to hold on to potential energy. And when we burn it or eat it, all we're really doing is prying open that container, letting the energy out and turning it into something useful, like heat and light. All right, so now that we know what it is, let's take a little tour of the world of fuels that we bump into every single day, from our dinner plates all the way to our car's tank. And what's really wild is just how many different kinds of fuel there are. I mean, you've got food, right? That's our biological fuel. Wood, one of the oldest fuels humanity has ever used. The sun, which is the ultimate source of pretty much all energy on Earth. And then, of course, the ones we usually think of: petrol, gas, coal, and even stuff around the house like paraffin and candle wax. They are all just different packages for the exact same thing: stored energy. Now, this is a concept that just blows my mind. The fuel for your body, the food you eat, it ultimately traces its energy right back to the sun. Plants soak up that sunlight through photosynthesis, and when we eat those plants, or we eat animals that ate the plants, we're just moving that original solar energy into our own bodies. It's amazing. So how much energy are we talking about here? Well, the average adult needs about 8,700 kilojoules a day. Now, that number might not mean much, so put it this way. That's about the same amount of energy it would take to boil 20 full kettles of water. All of that just to keep your body up and running. We can basically sort all these fuels into two big groups. On one side, you have natural sources, things like wood and food, which we get directly from the world around us right now. And on the other side, fossil fuels. You can think of these as ancient sunlight. They're the stored-up energy of plants and animals that lived millions of years ago, all compressed deep in the earth to become coal, gas, and oil. And hey, let's not forget the smaller guys. Fuels like paraffin for lamps or stoves, and even the wax in a simple candle, they're perfect little examples of stored chemical energy being turned into light and heat, right when we need it. Okay, so we know that fuels store energy, but how do we actually get that energy to, do something? This is all about energy transfer, how we get potential energy to become action. Now, before we go any further, we have to talk about this absolute golden rule of physics. It's so important. We never, ever make energy out of thin air, and we never really destroy it. We just change it. We convert it from one form, like the chemical energy in a log of wood, into another, like heat or light. And that brings us to this really simple but powerful idea of input and output energy. Think about literally any machine or system. To get it to do its job, you have to put some energy in. That's your input. The energy that comes out as a result, that's your output. Every single process, from a car engine to your own body, works this way. A light bulb is the perfect example to explain this. The input energy is electricity. The system is the light bulb itself. The useful output, the thing you actually want, is light energy. But as you know, if you've ever touched a light bulb that's been on for a while, you also get a non-useful output, heat energy. That split between useful and wasted energy happens everywhere. All right, let's get to the most dramatic part, the most common way we release all this stored energy: fire. So what's the secret? What are the essential ingredients for combustion? Well, it turns out it's a surprisingly simple three-part recipe. Let's just ask the question directly. Say you've got a piece of wood. We know it's a fuel, it's packed with energy. So what else do you absolutely have to turn that stored energy into a nice roaring fire? And the answer is something called the fire triangle. You need three things, and this is the important part. You need all three of them at the exact same time. First, you need your fuel, the stuff that's going to burn. Second, you need heat. That's the input energy to kick the whole reaction off, like a spark or a match. And third, you need oxygen. That third part of the triangle, oxygen, is the real secret ingredient that's just hiding in plain sight all around us. See, fire is a chemical reaction, and oxygen is the gas in the air that lets the fuel combust and release its energy super, super fast. What's really interesting is that if you look at the air we breathe, oxygen isn't even the most common gas, not by a long shot. That's nitrogen. But that 21% that is oxygen, turns out it's the perfect amount to let us have useful, controllable fires without the entire planet just bursting into flames. It's a pretty good balance. And here's the most practical and frankly life-saving part of the fire triangle. It's not just the recipe for starting a fire, it's also the instruction manual for stopping one. If you take away the fuel source, or you smother the fire to get rid of the oxygen, or you doused it with water to remove the heat, if you break any one of those three sides of the triangle, the fire just collapses. It has to go out. So, after all that, where does this leave us? We've figured out what fuel is, we've seen all its different shapes and sizes, and we've even uncovered the universal secret to fire. Now we can talk about what we do with that knowledge. Look, if you only remember three things from all of this, make it these. Number one, fuel is just energy in a storage container. Number two, that energy is never actually lost. It just changes its costume. And number three, the fire triangle, fuel, heat, and oxygen, that is the universal rule book for how things burn. And that brings us to one final big thought. From the food that keeps us alive to the electricity that lights up our homes, fuel makes our entire world possible. Understanding how it all works, how we unlock that ancient stored-up energy, that's the first step. The next step, well, that's a question for all of us. Knowing what we now know, what fuels are we going to choose to light up our future?